Calculating cardboard. This is session 3, unit 2. Brad now needs our help finding out which of the boxes is the cheapest to make. We found 16 different ways to box 24 baseballs. We need to check and see if some of those boxes use the same amount of cardboard or if there are some that use more. Yay! I'm so glad you're here. We need lots of help. What box should we use? They all can hold 24 balls. I'm so confused. If the volume of each box is 24 balls, then we need to look at the surface area. To find the volume, we looked at how many cubes a box could hold and used the formula length times width times height. To find surface area, we're now going to have to look at how much cardboard we need to cover the box. If you've ever looked at cardboard, notice that it's flat. It's a 2D shape. Surface area's equation is length times width. We measure it with squares instead of cubes. Notice how the square is flat right here, while the cube is 3D. How many sides does a square prism have? It has 6 sides, just like a cube or a dice. So check out this dice, guys. If you've ever played with a cube, a number cube like this, you can count. There are 6 sides. Here are the names for each side of the prism. There's a top, the back, the front, the side 1, and underneath is the bottom. There's no arrow for that, and if you notice, if you put your hand on top of a box and on bottom, they're the same. They are equivalent. If you put your hand on the front and the back, the box is also the same there. If you switch and put your hands on side 1 and side 2, those sides are also the same shape. Let's start by making a T-chart in our math notebook. Oops. There we go. And looking at one side at a time. Okay, so everyone go ahead and draw this T-chart with the sides on this side and surface area on the other. And then underneath we'll do total surface area. So you need to write top, bottom, side 1, side 2, front, back. Take a minute if you need to, and you can pause this while you write that down. Now we need to draw the box in our notebook. So everyone, remember how we start by drawing the Y. Then we take the Y and turn it into a tree or a kite, whatever you want. Then we bring the legs down, turn it into a table, and finally we connect it. So now you have a box drawn out in your notebook. Now we need to label all the sides of our box. So here is our box that we will be starting with. The first side is 6, then 2, and 2. We also have to find out what the other sides of the box is, being based on the sides being equivalent. What I mean is all of these sides that I have labeled blue with 6s are the same because they are the same length. Look how I use these little gray arrows to kind of follow the line to figure out that all of those sides were going to be the same length. They are all equal. Next, I did this with the pink too. I used the arrows and followed along. If you were to take a ruler and measure from corner to corner on all of these sides, you'd notice that they would be 2. Lastly, I did this with the yellow 2. And I used the arrows to follow along and see that all of these are 2s. So now we can move on now that all the side lengths are labeled. Okay, we're going to have to figure out the surface area for all the sides of the prism. Do you guys remember how many sides it has again? There's top, bottom, side 1, side 2, front, and back. That's 6 sides that we need to solve for. That means we're going to have 6 equations and 6 products to add together. How do we find surface area? Hint, we use squares of cardboard to measure the area. Squares are 2D shapes, so that means we're only going to need to multiply 2 numbers. If you remember back to our first slide, it told you which sides you'd need. Yeah, you're right. We multiply the length and width to find what we want, find the surface area. Let's start with the top of the box. To find the side lengths for the top of the box, you need to look and see which side lengths are equivalent. Remember, use the arrows to help you. So I'm drawing this arrow up, and I see that this side length is equal to 6, and I use this arrow, follow it up, and this side length is 2. The surface area of the top of the box can be found by solving 6 times 2. Now we need to record that in our chart. So next to top, I'm going to write down the equation, and then I will write 12 square units. We write 12 square units because we're using square pieces of cardboard to cover this. Now we need to find the area of the bottom. Thank goodness the top and bottom are equivalent. That means that they're the same. So we need to record that in our chart. We know that they're equivalent or the same because if we put our hands on the top of a box and the bottom of the box, they measure out to be the same. Let's find the surface area for side 1. Okay. What is the equation for side 1? Remember, use the arrows to help you. Well, side 1 already has this bottom part labeled as 6. I'm going to use this arrow and see that right here is 2. So the equation for side 1, this entire side, is going to be 6 times 2, and that's 12. So I'm going to record that in my T-chart. All right. So here's side 1, and here's side 2. So if you were holding a box, would we need to solve for both side 1 and side 2? No, we wouldn't need to because they're equivalent. This means that we just need to copy what we wrote for side 1 for side 2. That means to find side 2, we would have done 6 times 2, which equals 12 square units. All right, let's solve for the surface area of the front. What do you think the equation is for the front? Remember, equations have the equal symbol. The equation for the front is 2 times 2 equals 4. Let's record this. Do we need to solve for the back? Put your hand on the front and the back. No, we don't. We know that 2 times 2 equals 4. Please ignore Miss Hannah's mistake. She should have written 2 times 2 there and 2 times 2. All right, we did it. Now we just need to add up all the surface area. Oh man, this problem looks kind of hard. I wonder if I could break it down into smaller steps to solve it, like we do in our problem strings. Go ahead and pause the video and see if you can come up with a good idea. What is the total of all of these together? Wow, we did it. Great job, guys. The total surface area for this box is 56 square units. That means we would have to use 56 tiny pieces of cardboard to cover and make this box. I wonder if all the other boxes will use 56 square units of cardboard to make it. With your breakout group, please find out for me. Dave wants to use the box that requires the least amount of cardboard possible.